In 27, we have 4x squared plus 25y squared minus 24x plus 250y and plus 561. Let's work on this for 1 minute. And this is the end of chapter 11. If you have any questions, let me know. And all this is done. So we have these two sections to look at, 12.1 and 12.3. Does it shape up into anything?
Mm-hmm.
I hope not into a point,
No.
and obviously not into a parabola.
I think it's an ellipse.
If both are positive and one on the other side, it's an ellipse.
Yeah, both are positive and one on the other side.
Okay then. Do we need more time?
Yeah, x minus 3 squared. Yeah, and then y plus 5 squared and 4.
Okay, and the center is? Okay, let's do this.
I forgot that.
That's okay.
3
So,
and 5. No, 3. Yeah. 3.
so for these two, I'm sure you factored out a 4,
Yeah.
and you got x squared minus 6x, and then you added 9 and subtracted 9.
Yes.
Okay, now for these, you factor out 25 and you got y squared and you got plus 10y and divided by 2 and squared. I'm sure you added 25 and subtracted 25.
Yep.
And then you move this, if you want, from the very beginning to the other side.
Yep.
So this becomes a 4 and x minus 3 squared and minus 36
Yep.
plus 25 and y plus 5 squared and minus 625 equals negative 561.
Yeah, right.
So then I have a 4x minus 3 squared and plus 25y plus 5 squared. And I have, how much is this plus this minus this?
100.
100?
Yep.
Very nice. So now I have to divide by 100, and I have a 1 here. And then x minus 3 squared over 25 plus y plus 5 squared over 4. Definitely an ellipse. And the center is indeed 3 comma negative 5. Very good. Is the major axis on the x-axis or on the y-axis?
Why?
On the x,
X.
because this number is bigger and it's under x. So it will be, the major axis will be on the x-axis.
Right.
Very good. Awesome. Any questions on this?
Nope.
Do we need more examples on shifted conic sections?
How do we find the foci on that? Okay. The ellipse.
Isn't that a squared minus b squared?
Yes, if you remember, I have to determine c,
Right.
which is the square root of 25 minus 4.
Oh, yeah.
But then I have to make sure that I consider the fact that the center is not 0, 0.
Right.
So I have to shift that 3 to the left and 5 down. Okay. Do we need more examples with the shifted conic sections, you think? Paul, are you okay? Did you?
Yep.
Stephen, are you okay with this?
Yeah.
Do you need any help?
I just got to the second last part. Everyone else was finished.
Okay, you need more time?
Oh, I just copied it.
Okay, and let's graph now with the apps. Yep, the conics. We know it's an ellipse, and we know it's going to be A. It's going to be on the x-axis, right? So I'm using A, and then A is 5. Okay, B is 4. I'm sorry, B is 2, and then H is 3, and then K is negative 5. And I graph. As you see, 3 to the right and 5 down. 3 to the right, 5 down is the center. Okay, any questions? Any questions? Yes. Do we need another example? Do we want to work on one more? If you say yes, let's choose. If you say no, let's finish up with the 2 sections in chapter 12. So we want to find something else? The shifted conics? Yes or no? Let's work on 24. Since you're not sure. Okay, 24, last one. It caught my eye. I have no idea what this is. I know it's not a problem. (9x squared minus 36x plus 4y squared equals 0). Okay, last one. Do we need more time? We'll see in a minute. So I did factor 9, correct? And I have x squared minus 4x, and then obviously plus 4 minus 4.
Right.
Then I have the 9, and I have x minus 2 squared, and minus 36, and plus 4y squared equals 0. And then I have the 9, x minus 2 squared, plus 4y squared equals 36.
Yeah.
Very clearly that I have to
Divide.
by, very good. So I have x minus 2 squared over 4 plus y squared over 9 equals 1.
Yeah.
This number is larger than this number, which means the ellipse will be on with the major axis on the y-axis, and the center would be,
2,
is that clear?
Where do we get the minus 36?
Because remember, this is the x minus 2 squared, but then I have to multiply 9 by negative 4 to get the negative 36.
Yes. Yeah, I missed it.
Is that better?
Yeah.
Okay. Good. I know we only have a few more minutes. I just want to talk, we only have two more sections left, 11.1, I'm sorry, 12.1 and 12.3. I'm not going to get into details right now about the sequences and the series and everything. I just want to talk about the summation. This is the preparation. Summation notation. Summation notation. As you know, every time we invent a notation, what follows afterwards? Its properties, of course.
Yeah.
It comes with the whole thing. Right. Okay. So let's suppose I would like to know how much is 1 plus 2 plus 3 plus 4 plus 3 dots, exactly 3 dots, plus 100. Now, there is a way of condensing all this, let alone forget about what the number is yet. But there is a way of condensing this. And because I have a sum and not product or some other operation between 1 and 2 and between 2 and 3 and between 3 and 4, we're going to use what it's called the summation notation because it's all these terms are added. We do not use the Latin S. It's not good enough. So instead, because the Greeks are so smart, they gave us their S, which is this letter, which is so much more suitable for what I'm going to write next. This is good, but it's not as good as this one. It's still S, it still stands for sum, but it's the Greek letter S. Why this is so much better and more suitable than this one is because I have to write a lower limit, I have to write an upper limit, and it will be kind of inconvenient to write something on top here and below here. So first of all, what am I adding? Well, I'm adding a quantity called I that starts with I equals 1 and it ends with what? Exactly. This is called the lower limit of the summation notation. This is called, of course, upper limit. And it is a very elegant notation. So now watch this for a second. See what this means. The summation says to me, when I is 1, I have 1. Then the sum says plus. I move on. When I is 2, I have to add 2. Then the sum says plus. When I is 3, I have to add 3, and then the sum says plus. And I continue till I finish with I equals 100. So it's a very elegant way of presenting all this. Okay, now, what if I want to add from I equals, and by the way, I is not the only index, so I can use K. I can use J. From K equals 1 through 5, let's say from 3K plus 2. I'll come back and we'll determine the sum. I'll show you the formula in a minute. So, well, now I have to understand the sum of these two terms in the following way. It's the sum from K equals 1 through 5 from the first portion plus the sum from K equals 1 through 5 from the second portion. That's one property of the summation notation. The summation of the two generic terms is the sum of the first plus the sum of the second, or the difference. Okay, now I'm looking at the second one, and this is another property because it's 3 multiplied by K. It can go in front of the sum. 3 multiplied by K, so the sum from K equals 1 through 5 of K, plus the sum, this is 2 multiplied by 1. I put the 2 in front, the sum of 1 from K equals 1 through 5. So basically, I showed two properties here. So here's the first property. The sum from K equals 1 through N from AK plus BK. Two generic terms based on K. So this is the sum of AK from K equals 1 through N, of course, plus the sum of BK from K equals 1 through N. This is the property that we used here. This is our AK and this is our BK, so it's the sum of the first one plus the sum of the second one. Here, from this step to this step, I used a different property, which is the sum from K equals 1 through N from a number, let's say P, multiplied by AK. This is P, the sum from K equals 1 through N from AK. Now, can I determine this? Yes, because luckily this number is not too big. How do I determine this? I have a formula for that in a blink. So, K equals 1, 1. K equals 2, 2. K equals 3, 3. So I have to add 1 plus 2 plus 3 plus 4 plus 5. That's what this means. 1 plus 2 plus 3 plus 4 plus 5. What does this mean? 1 plus 1 plus 1 plus 1 plus, exactly. When K is 1, 1. The sum says plus. When K is 2, another 1. When K is 3, another 1. When K is 4, another 1. When K is 5, another 1. So this is 5 plus 5 is 10. 3 plus 4 is 17. 7 plus 10, right? Am I correct here? No, I'm not correct. So this is 10, 15. So 3 times 15 is 45 plus 1 plus 1 plus 1 plus 1 is 5. 5 times 2 is 10. So the answer is 55. Coming back to this. This is very important for Calc 1. This sum, actually the one with N up here, the general one. So if I have the sum of I from I equals 1 through N, we used to prove this and we can still prove it. But we used to prove this in this class, not anymore. So this is n plus 1 divided by 2. If you'd like to prove this, we can prove it together. We only have 3 minutes, so if you want, we can do it next time. So now, because I was asked to find the sum from I equals 1 to 100 of I, what will you tell me to write?
100 times 100 plus 1.
Okay, so I'll stop here for tonight, and